Yes? All right. Thank you. Welcome, everyone. What you just saw before was like a small creative coding sketch I made in P5.js. I'm really big fan of creative coding, so I hope you enjoyed that like screensaver-like thing. I will share the source code as well if you're interested in it. My talk is failure is not an option. Durable execution plus Dapr is rocket emoji. I'm not sure how you would like translate that. Maybe it's like amazing. It's awesome. I don't know. Just whatever you feel like. And I'm a big fan of VS Code and all of its extensions. So I'm not using, I am using slides, but I'm using them in VS Code. I'm using an extension called Code Tour, which allows you to record and play back and do like a guided tour through a Git repository. So everything what you see here is in Git. I will share the link with you later, so you can all view it yourself and try all the code samples yourself. So don't worry about that. But that's what I'm using. This talk is about failure and how to also overcome failure or limit the impact of failure. And maybe some of you are as old as I am and seen this message in real life. It's from Windows XP, task fails successfully, which is of course like is a very weird message to show to your end users. But it's basically what this session is about. Because if something is failing, well then make sure that the impact is like as minimal as possible. Or maybe you can actually overcome from that failure and still be successful. So that's why I chose this image. So I'm Marc Duiker. I'm a developer advocate at Diagrid. That's a company founded by the co-creators of Dapr open source project, Mark Vossel and Jeroen Snijder. And we build products for developers to help build and run distributed systems at scale. I'm also one of the Dapr community managers. There are 3 of them in total, and every other week we host like a Dapr community call where we like highlight some new features in a new Dapr release, and also have Dapr end users come over and talk about how about their experience with Dapr. I consider myself a long-time developer supporter, so if you need maybe like a nudge in your developer career, or maybe you want to do something more in the developer community, please reach out. I'm always happy to help. If you want to know a bit more about me and all of my too many creative hobbies, like creative coding, creating pixel art, feel free to have a look at marcduiker.dev. Maybe some of you went to like Joe's talk earlier. She also showed like VS Code pads. That's one of the things I also contributed to. A lot of the, let's say, animals in here I've created. So for instance, if you want to literally have like a virtual rubber duck in your IDE, you can use the VS Code pads extension and then talk to your rubber duck to solve your own problem. And like different animations and stuff like that. So I'll keep it on for now. All right, so let's move on to failure, right? So let's start with failure. And I did some research on the internet, and there was this great blog post on the IEEE blog. It's already quite old, from 2015, and it's named "Lessons from a Decade of IT Failures." So they looked at all the IT failures, or all the public ones between 2005 and 2015, and they did lots of analysis on them. And one of these things, well, the first one is actually show this chart, which shows like what's the cost involved in all these IT failures. And as you can see here, the biggest ring is like $10 billion of cost. And here you can see it distributed across like different regions and also over time. So it's very clear that there are like dozens and probably hundreds of billions of IT costs due to failing IT systems. Now, I'm not claiming that by following this talk, this will be like reduced to zero, right? There will always be failures, but you can definitely like use some nice tools to maybe sometimes minimize the impact of those failures. One of the quotes actually was really quite interesting to me. It was about the Knight Capital Group, and within 45 minutes of trades, they lost $440 million by a change in an algorithm they pushed to production. So yeah, that's of course not in a situation you want to be in. Of course, like there's always people involved, mistakes can happen, but I really hope that none of you will like push this kind of change to production and lose like so many millions in 45 minutes. So maybe you've seen Leila's talk yesterday about the modular monolith, because she claimed that it's very difficult to build these distributed applications like in a good way, because it's complex, right? And that's definitely true. There are a lot of moving parts in these distributed applications, lots of different services, each with their own configuration, lots of different state stores are also involved, message queues, and so on. And you need to make sure that the communication is secure. You need to have like observability in place, but these things also need to be resilient. And there's also things that can go wrong. So who here has heard of the fallacies of distributed computing? Can I see like a show of hands? Okay, some people have heard about it. So it's a set of false assumptions programmers new to distributed computing often make because they either really don't think about the issue or they just really don't know about it. And one of the pretty most well-known ones is, of course, that they think that the network is reliable, right? I make an HTTP call and I think the thing on the other end will always be like available, nothing happens in between. That's, of course, not true. I'm not going to go through all of these things. I definitely want to highlight this last link here. That's a playlist on YouTube by Uri de Haan from Particular Software, who gives like a 5-minute intro into all of these fallacies and explains why they're important to know about. So definitely look into that when I share the link with you later. All right. So if you're in this business of creating distributed applications, right, and it typically happens with large enterprises where many different development teams are involved, and they all need to go in their own pace, but still make some kind of one coherent system. Then you definitely need to think about these cross-cutting concerns, right, about security and observability and resiliency. And that's then where Dapr comes in. Dapr is the distributed application runtime. So who here has heard about Dapr? Quite some people, nice, okay, perfect. Okay, so who is actually using Dapr at the moment? Okay, some folks are, okay. Please come see me afterwards, because I might have something for you that will be useful. So Dapr is about like 5 years old now. So in this year, in October, it will be 5 years old, and there will be like a virtual Dapr conference called Dapr Day. Marc Duiker will give the keynote, so please need to join this online thing. And Dapr provides APIs for building secure and reliable microservices, and it's used by a lot of big companies. So if you are running your workload with Dapr, Dapr uses a sidecar pattern. So that means that next to your application, which runs in a process, there's another process, the sidecar process, and Dapr runs in that sidecar process. And Dapr takes care of all of the heavy lifting. So all of the communication that happens between services and other resources, that all goes through the Dapr sidecar. And that's great because Dapr has observability built in, and since all of the communication goes through the Dapr sidecar, you have like good tracing insights there. Also, Dapr comes built in with all kinds of resiliency policies. I will demonstrate some of these policies later in this talk. And Dapr is also secure by default as well, and you can also configure quite granularly which services are allowed to talk to each other, which services are allowed to publish messages on the message broker, to communicate to which state stores, and so on. Another benefit of Dapr is that it provides like a whole suite of API building blocks. So in this session, I'm going to talk about mostly workflow and a bit of servicification and state management, since those are in my demo. But as you can see, there are many more different building blocks. There are actually 10 at the moment here. I'm only listing 9. But since Dapr 1.14, there's now also a jobs API that you can use to schedule tasks. So your Dapr workload is usually run on top of Kubernetes. It can either be like plain Kubernetes or any of the managed Kubernetes on the major clouds. I do want to call out 2 services. So there's also Azure Container Apps, which also supports Dapr, and one of the Digrid products called Catalyst also supports Dapr. So Catalyst is like Dapr as a service. You can basically call Dapr API from any type of compute, also like a serverless function, for instance. The really nice thing about Dapr is that the API is decoupled from the underlying resources. So here we see a list of all of the APIs. But if we pick, for instance, the state management API, so Dapr, you can do a key value pair state management with Dapr. But Dapr itself is not a state store. But you can configure Dapr to use like many different state stores via like configuration files, via YAML files. These are named component files. And that allows you to easily like swap out different components, and you can use it to have your workload land on different clouds. But I mostly use it to switch between my local development environment and my production environment. So if I'm developing Dapr applications locally, so here I have like 3 applications, I can use like a local file which contains some keys, just to make sure you don't check it into source control. I use like the provided Redis container for pub/sub messaging, because if you install the Dapr CLI, you get this Redis container. And I can use like an in-memory store when I use my key value API. So that's what I'm using when I'm developing locally. But then when I push to the cloud, I can swap out these component files. So in your CI/CD pipeline, you switch to a different set of component files, and then you can use like Azure Key Vault for your key API, Service Bus for your PubSub messaging, and Azure Cosmos DB. And with these changes, none of your application code is changing, because in your application you're using the Dapr API and not all of these specific resource APIs. All right, let's move over to durable execution. So the problem is that a lot of IT systems are failing, and of course for different reasons, and a lot of organizations are losing money about this, and of course they don't want that. So ideally, we can't really prevent systems from failing, but we can do something about maybe like retrying stuff more, right? Or if like a process goes down, maybe just restart that process, and hopefully automatically things will start working again. And we can also do something about just limiting the impact of failure. So that's definitely happening, and one of the things is called like durable execution. So what does it mean? Well, it's like a way of running code in a stateful way. So that sounds a bit weird, but in case that code then stops, if the runtime then stops, a new process is started, and then the code is still run to completion. Now, if that sounds familiar, you might think of, okay, maybe that sounds a bit like maybe a workflow engine, and you're right, durable execution is just like a new fancy term, but it actually means a lot of the same things as having like a workflow engine, because most workflow engines are also stateful, right? You define a set of activities, they are executed in a certain order, and the workflow state is all usually persisted. Now I'm going to show you an animation that shows what communication happens between the workflow and a state store typically. So this is not specific to Dapr Workflow, it happens with all kinds of workflow systems. So a lot of data is persisted. So for instance, the workflow ID and the payload is persisted, the first activity input is then persisted, and then when the first activity is done, also that output is persisted. Then the workflow will replay, so it will not actually continue to the next activity, but it will restart. It will read the data from the state store, then it will schedule the second activity and log that input. When activity 2 is completed, it will also log the output. Then it will replay again from the start, read all the data back from the state store into memory. Then it will schedule the third one and actually log the input again. And when the third activity is completed, it will also save the output again. Then the final replay will happen, and it will check that all of the data is already in the state store. So it will rehydrate that, and then finally the workflow is completed, and also that output is stored in the state store. So as you can see, there's a lot of I/O going on in these workflow systems, and yeah, you really have to think about that a bit, because you also want your performance to stay good. So I'll give you some tips later as well. So there are like many different workflow systems, also many different ways to author your workflows, right? So it usually start out in a bit of a visual way. Maybe you've like used logic apps, or maybe you use like BizTalk. It's more like dragging some stuff over. But yeah, the authoring types that are like now very popular are more like code-based, right? And yeah, those are ideal for us because we're developers. We like to deal with code. So also writing, I think, authoring our workflows is good for us if we can do that in code. Especially because it's like part of the source code, so hopefully there's like kind of a PR review when you submit it to source control, and you can also unit test your workflows, which I think is really a big benefit. So there are different types of workflows code solutions. So a well-known one is, for instance, temporal. There's restate, Azure durable functions. I've used that a lot. So who here has used durable functions? Okay, quite some people. So if you use durable functions, and if you then look at Dapr Workflow, you'll see a lot of similarities. A lot of the method names are the same, and that's because the guy that wrote durable functions, Chris Gillum, is also the person who helped us with writing Dapr Workflow. So I will share like a couple of workflow patterns that are typically used when you use these workflow as code solutions. So the first one is task chaining. That's the most basic one, and you use this when the order of the activities is important. So I first want to execute activity A, and then B, and then C. And that's typically because the output of A is then used as an input for B. Another pattern is called the fan-out, fan-in one. So here the order of the activities doesn't matter at all. So these can be like all scheduled like async. We don't really care which one gets executed first. But the nice thing is that we can instruct the workflow to actually wait until all of these activities have been completed. Or we can instruct the workflow to just wait until the first one has completed and then continue. So this is a really, really powerful pattern. The next one, monitor. So that's often used when you want to do some kind of a reoccurring activity and then wait a bit. So maybe you want to do like a nightly cleanup of some cloud resources. So what you can do there is you can use this first activity to call an API endpoint in your cloud to clean up some resources. Then you can use like the timer object of the workflow context to introduce a delay. So maybe you want to wait for 1 day and then you want to execute it again. And the continue as new instructs the workflow to continue as a new fresh instance. This is different than the replay behavior because replay behavior belongs to the same ID and builds up a history for that workflow instance. But continue as new instructs the workflow to forget about the entire history. The final one is the external system interaction, also known as like human interaction. The nice thing about this is then the workflow will wait until it has received an event that comes from the outside. So this is quite typical when you do kind of a approval process. So for instance, you want to buy an expensive laptop and you need approval from your manager. And then you can run an activity that sends a message to your manager for, okay, please can I buy this expensive laptop? And then the manager uses a different system and that will send a message back to this instance of your workflow. And then based on the payload of that event, you can decide, okay, this is either approved and we go this route, or this is not approved and we go to the other route. And what happens often is, of course, you combine these different patterns into one workflow, right? So that's what happens. So as an example here, this workflow is started when a message is received from a message bus. We do an activity where we use the Dapr secrets API to retrieve a secret. Then we wait for an external event, and then we call two activities in parallel, one that stores the event result and one that invokes an API. And only once these two have completed, then we continue with the final activity, D, which puts yet a message on another bus. So this is quite a typical way of doing workflow stuff. Okay, it's almost demo time. So a bit about behind the scenes of the workflow engine. So there are some different moving parts at play here. So your workflow application that contains your own workflow code, right? So the workflow, you can write it in different languages. I will show it in C#, but you can also write workflow in Java, JavaScript, Python, Go. So the workflow app contains your workflow and activity definitions. And it will also do the execution of the code. But the scheduling of that workflow and all of its activities, that's been handled by the Dapr sidecar. So the Dapr sidecar contains the Dapr Workflow engine. And as soon as you start up your application, the Dapr sidecar will also spin up, and then a gRPC stream will be established between those two processes. And there will be a lot of communication going back and forth between the two to schedule all the activities, but also to provide the input and output results from the workflow app, but also completely back to the append-only state store. All right, so I'm going to do like a workflow demo now. Quite a simple application. It's like two applications. One has the workflow, and it's going to do kind of a validation on an order. It will check an inventory, which is like a key value store. If the item is present, and if there's enough inventory, we actually continue and we'll request some shipping costs. So we'll check with 3 different shippers what the shipping cost will be for this item. We will choose the cheapest one, and then we'll register the shipment also at this shipping service. All right, moving into this folder. So this is a .NET 8 application, and we're using the Dapr Workflow package here. That's the only dependency we have, and we're using the most recent version. That's version 1.14. It came out 2 weeks ago. The program CS file of that, I'll just highlight a couple of things, not the complete thing. It's very important when you use Dapr Workflow that you are registering the workflows in your setup. So here we have the add Dapr Workflow extension method on the service collection, and here we are registering the workflow and also its activities. So if you don't do this, if you just create your workflows, if you write them but you don't register them, the Dapr sidecar has no idea that there are like workflows and activities present. So this is a step that you need to do. So this is quite different, for instance, when compared to durable functions, for instance. This application also contains a couple of endpoints. So one endpoint that we will call that will actually start the workflow. So we will make a request to validate order. That is using the Dapr Workflow client, and it will schedule a new workflow. We then provide the name of the workflow. We provided an instance ID. This is optional. If you don't provide instance ID, the Dapr Workflow engine will create one for you. And we provide an input. And what we get back is the instance ID again, but it's the same one that we already provided. But yeah, you need to remember that everything is asynchronous, right? We do not get back a real result of the workflow because this workflow could be like a long-running process that could take many hours or days to complete. So what we get back is the instance ID, and with that instance ID, we can actually query the workflow engine about its state. There was some additional endpoints to just manipulate the inventory. All right, so this is the workflow class itself. It's just a regular .NET class. We inherit from a base type in this Dapr Workflow package called Workflow, and we specify the input type and the output type. Then you need to override the run async method, and with that you get access to a workflow context that we will use, and this is the order input. So the first thing what we're doing here is we use the context to call an activity async. And we are calling it again by name, so we're calling an update inventory activity. We provided our order item, and what we get back is an inventory result. So that's here. And then we had it as a boolean, is there sufficient stock? If that's the case, then I have a list of 3 shipping services. So this is like clearly demo code, right? Because you probably want to query another API that gives you back all the different shipping services. This is just a simple demo. So what we're going to do now is we are going to call another activity for each of these 3 shipping services. So this is an example of fan out, fan in. What I first define is a list of task shipping cost result. So this is the output of the activity that I want to call. Then I'm iterating over all of these shipping services. So shipping service A, B, and C. I prepare a request for all of them. And here I call the activity get shipping cost with this request. But you can see, call this activity, I'm not awaiting this call. So with the first one example, I'm awaiting this call. So then the workflow will actually stop and it will actually execute this activity and then it will continue. But here I'm not awaiting this call. So the output here is just a task that will be executed later. So this variable, shipping cost result tasks, then contains like 3 tasks, and I want to execute all of them. And this is where the magic happens. So here we do await task when all, and this is the part that then starts the fan out, but then also waits until all of these tasks have been completed, and only then we will continue with the rest. So when all of these 3 tasks have been completed, I can then find out what is the cheapest of these shipping services. And then the next part, I want to register my order for this shipment provider. So I'm calling yet another activity, call register shipment, and provide the shipment request, and then I get back a register shipment result. Now I wrap this in a try-catch just to illustrate that you can do a bit more like to prevent some more failure for what's happening. So in case this call fails, we can choose like another path, right? We can choose like to do like some kind of a compensation action in case this action fails. So in case this register shipment fails, I already updated my inventory because that was the very first step. So as an example, the compensation action I'm doing now is I'm actually undoing my previously done inventory update, right? I mean, it's just a basic demo. In a real life situation, you probably want to maybe update your inventory in a later stage. That's also fine. Or choose some kind of a different compensation action. It's totally up to you. What do you want to do about this compensation action? But in this case, I'm actually undoing my update to the inventory, so it's restored in the previous state. Okay. I'll show you just one example of an activity because all of them have the same structure. So again, an activity is also just a C# class. You inherit from workflow activity, again from the Dapr Workflow package. Again, this is the input type, this is the output type. I have a constructor here because I am actually injecting the Dapr client because I'm using that to manipulate the state store. Again, you have to override the run async method. And what I'm doing here is I'm using the Dapr client and retrieve the state. I want to see, do I have this product in my inventory? And if I do have something in my inventory and the quantity is at least as big as the quantity that I'm ordering, then it's all good. I'm creating like a new inventory object, and then I'm saving that again using the Dapr client. All right, I'm not doing all the other activities because we don't really have time for that. Okay, sorry, Ducky. I'm just removing you again. All right, so now it's time to run them. I'm not going to do the simulate issue. Let's do first like a happy path, and then we'll do like what happens if the process is dead. So I'm using the Dapr CLI and with the Dapr multi-app run feature. So I'm gonna click or type Dapr run -f and then dot. This will load this file. So this file is located in this folder, this dapr.yaml file, and this contains the configuration of what I want to run now locally. So it points to a resources path, and that contains my component files, which state store I'm using, what kind of Dapr configuration I'm using, and it has a list of all of my Dapr applications that I want to run in one go. So in this case, I'm running a workflow application, and I'm running a shipping application. Okay, so let's run this. And logging is set to quiet for both, so you'll see lots of logging statements coming by. So now I have like 2 applications up and running, the workflow application and the shipping application, and there's also a state store, which is a Redis container. So now I'm going to call this validate endpoint, and for that I'm using yet another VS Code extension called the VS Code REST client. If you have this REST client installed, you can write these .htp files or .rest files, and you can use like variables, and you can write your endpoints like this. I'm going to do a post to this workflow URL, to this inventory endpoint, to actually make sure I have enough inventory. So there's this button here above this endpoint called send request, and that will execute my request, and then we'll see the output here on the right. So this is just restocking the inventory, so this is no workflow stuff yet. So I now should have enough rubber duckies to buy. Yes, I've got 5, perfect. So now I can start the workflow. So I'm going to call the validate order endpoint and provide this payload. I'm going to buy 2 rubber duckies. So I'm going to send this, and we'll see some stuff happening here, right? We see some log statements, getting shipping costs for this specific order. We see the shipping cost that all of these shipping services give back. One of them is the cheapest, and that will be selected as the actual provider. And then we see some more statements that orchestration status completed. So that's exactly what we want to see, but this was the happy path, right? So this is maybe a bit boring. I do want to show as well, because this doesn't give a result back, right? But the workflow does have a result, so I'm going to do like a get to this workflow endpoint. So workflow/Dapr, and then provide the instance ID that I gave earlier, and that will actually give the actual status of the workflow instance. So in this case, this validate order workflow is completed. It shows me what kind of input I gave, but this is also the output of this workflow. All right, so let's do this again, but now, as soon as I have started again one of these runs, I will just completely stop the Dapr CLI. So that means I will stop both the workflow application and the shipping application. So let's see what happens then, and then I'm going to restart it again. So I'm going to do the same thing. I'm going to start it, all right, but now I'm going to stop it. All right, so now everything is dead, right? So there's no workflow application, there's no shipping application. And the last thing what happened was that there was a logging statement from the shipping application that we were like retrieving shipping costs, right? But I introduced a bit of a delay in that shipping service, so it did not actually respond back to the workflow application. All right, so things are broken. Now let's just simply restart the whole process, and let's see what happens. So I'm going to run Dapr run -f again. There we go. So this is where we left off, but we can see it's continuing now, right? So we're getting the cost again for this order, and one of them is probably selected. Actually, we don't see it. Of course, this is the demo cast not being happy with me. Okay, let me do this one more time, because this needs to work. This is not nice. First, let me make sure that I have enough in stock. Oh, connection was rejected. Oh, maybe the Wi-Fi is not being happy. Okay, let me quickly. Oh, that should be fine, actually. Let me first start everything up again and restock. Okay, so I'm going to try this again. I'm making a post stopping this process, so everything is down. I will restart, and hopefully it will continue again. Right, so this is the point that we left off. We communicate with the shipping. And yeah, it did work now. I'm not sure why it didn't before. But now we see that the orchestration is actually continued. So now it actually successfully completed that earlier run that was broken off. And also if we get the information straight from the status endpoint, we see that the runtime status is completed for this instance. Right, so this is sort of not completely self-healing, because I am actually restarting the process again. But of course, if you're running this on Kubernetes, then if a pod maybe goes down, it will restart again. So then this will happen automatically. But it definitely indicates that this workflow, because of the state is stored in the state store, it's being able to actually complete the workflow if it has been broken off earlier. All right. Okay, so now let's simulate the other issue. So this is the endpoint in the shipment service. I'm actually stopping this. This is the shipment service, and this returns this shipment result. But let's just fake that this shipment result gives back a server error 500. So this should trigger the try catch block. So this should trigger the compensation action to undo the inventory update. So now I'm going to run again. All right, and I'm going to start this again, make sure that I have enough inventory. All right. So now again, I'm calling the endpoint, and even though that the register service endpoint will give back a 500, I still expect that my orchestration will run successfully, because I am doing this try catch, and I'm doing this compensation action. So that's my way of saying, you're allowed to go to this alternative path. So that's why it's still an acceptable result for me. Okay, I'm doing this, getting shipping costs. But then here you see indeed we have a failed to register shipment for order. And here you see that we have the compensation action, reverted inventory update for this product, and we set it back to quantity 5, which was our initial value. And that's why our workflow still has a completed status instead of a failed status. Right? So this is just a way of dealing with failure and trying what is an alternative path that still makes sense for your business. All right. So workflow systems in general, and also workflow as code system, still have some challenges, and I'm going to walk you through a couple of those. The first thing is that workflows need to be deterministic. So workflows are being replayed, as you saw in this initial animation that I showed. And every time a workflow is replayed, it needs to it should result in exactly the same state as before, right? It should always have the exact same outcome. So it means that you cannot use non-deterministic operations in your workflow. So for instance, that includes creating random values using GUIDs, or using datetime now, or maybe calling endpoints directly from your workflow instead of an activity. So what you see here is something that you should not do in your workflow. For instance, creating an order ID with GUID, new GUID in your workflow, and using this as a parameter when you call a new activity. When you call an activity. So what happens then if you do this, and the workflow will replay, it will create a new order ID when it replays, and that will then mismatch the state that is present in the state store. So when these things do not match up, you have a corrupt history then. So that will not work. Luckily, there are some methods on the workflow context. And so this is the workflow context. So it has some helper methods for GUIDs, but also for current UTC date times. So that should definitely help you. If you still need to do something that is non-deterministic, just make sure you wrap it in an activity. Because you can do anything in an activity, it doesn't really matter. So make sure anything non-deterministic, just wrap it in an activity. The other thing that your workflows need to be is they need to be idempotent. So if they are run more than once, that should not have any side effects. Again, so this is a bit different than the first one. And this is because Dapr Workflow and many of the other workflows, they guarantee at least once delivery. So an activity will be executed once, but an activity might also be executed twice or even 3 times. So your code needs to handle those multiple executions of your activities. And that could maybe be a result if you do like a SQL insert, right? And you use some kind of product ID as the primary key. And if you want to do like the exact same insert with that exact ID, well, that will not work, right? So you either need to make sure that you first maybe do a read before you do an insert, or maybe you need to do like an upsert instead. This is very specific to, of course, like what kind of database you use. But definitely make sure that your code can be executed like multiple times without having side effects. Another thing which is quite tricky is what if you have like breaking changes in your workflow? Because again, if your workflow is long running and you want to like deploy a new version of your workflow, but you still have workflow instances that are in flight, which are not completed yet, it means you have some old state in your state store from a certain version of your workflow, but you're now having a new workflow version deployed, and that does not match with the state in your state store anymore. So again, that can lead to problems. So as an example here, I've got a very small workflow with 2 activities, and the input of them is this string, this order item string. But in my next iteration of this workflow, I changed the input item of the second one to be the output of the previous one. So result A, which is now an int instead of a string, I'm putting that in as my second argument. And the rest stays the same. But this is now a breaking change for my workflow, right? Because any workflows that are in flight, they still have a string stored, and that will now be loaded, or will be loaded in, and there'll be like issues at runtime, because we have this string, but this now expects an int. So ways around that could either be just like stop accepting requests for the current workflow, right? And make sure all of them are like completely done, all your workflows, and then update and then accept traffic again to your workflow. So that's one. Or indeed do like this and increment all of your workflows, so never actually touch an existing workflow once it has been in production. Always create new ones, but then of course you also need a way to actually update other code that actually use this new workflow. So again, there's no really super good solution out here. Definitely something to think about. Final thing about these workflow challenges is the workflow and activity payload, right? So make sure that you only pass very small objects between activities, because as you saw, everything is persisted to a state store and also retrieved from a state store. So there's a lot of serialization and deserialization going on. So if you have like a very large object that you want to pass between different activities, that means that there's a lot of like a performance overhead going on. So in this case, I have like 2 activities, and one of them retrieves a large document, and this document is used as an input then for the next activity. Please don't do this, because this document will be in the state store twice. First as an output for this activity, but then as an input for this activity. So there's like redundant information stored. But what I definitely try to recommend is try to also consolidate and be pragmatic about all of these activities, right? So these activities, they do not need to be like very micro units, right? So be pragmatic about the size. It's totally fine. Do the retrieval and update and storage in the same activity, right? So make that your unit of work, so you're not passing around very big objects between activities. All right, let's switch gears a bit and talk a bit about the built-in Dapr resiliency. So Dapr has different ways of handling resiliency. One of them I want to show you first is how you do like resiliency when it comes to service invocation. As I mentioned before, you do not actually communicate directly to another service, but your application talks to the Dapr sidecar, and this Dapr sidecar talks to another Dapr sidecar, and that Dapr sidecar talks to the application. And because of this, Dapr has like built-in retry policies, and because Dapr is in control of all of the communication, and it already comes with some default when it comes to retry policies. However, you can override them, and I will show you how that's done. So what's happening here is we have two applications. They communicate via service invocation. We're going to send something from application A to application B, and application B will store something in a key value store. All right, I need to get out here in this folder. So again, this is a .NET 8 application using Dapr ASP.NET Core 1.14. And what happens here is I have configured this HTTP client. So whenever I want an HTTP client injected, I'm using the Dapr client to create me an HTTP client where I set a specific header. And this header is the app ID header. And I set this app ID header to application B. And so that is the target application that I want to communicate with. So in this service invocation endpoint, I mean, I didn't have a lot of inspiration for naming endpoints here. I'm injecting the HTTP client, which already has this app ID header set, and I'm doing a post to the /profile endpoint. So I'm calling application B /profile. All right, application B is also a .NET 8 project, same setup. And what happens here is, well, there's a state store component name that I'm using, and I'm injecting also the Dapr client, and here I'm saving this Dapr this profile information in my state store. So I didn't show you that in the previous example, but this is how you actually configure what type of state store component you use. So this is a component file that lives also in the same Git repo, and just by making sure that this metadata name is the same label as you've used in your application code, Dapr knows how to match up what kind of state store you use. In this case, I'm using the Redis state store, which is running locally as a container. And again, I'm using the Dapr multi-app run file to start these two applications, application A and application B. All right. We can do first do the happy path, so let's just... let's make sure it runs first, actually. All right, so both applications are now up and running. And we're going to make this call, and this is still the happy path. So we see some log statements from application B that is saved to the state store, and application A that it's communicated with the application B. So this is all fine, this is as expected. So now let's simulate an issue with application B. So what I'm doing now is I'm not using Dapr multi-app run. I'm just going to run application A first. Then I'm going to make the HTTP call. Then I'm going to wait a couple of seconds. And then I'm going to start application B. So I'm going to do this. And this is application B. OK, so I'm starting application A already. And I will copy the commands to run application B, but not execute that just yet. All right, so I'm gonna run the same endpoint, the service invocation endpoint, and make the request, and then we'll see like nothing's happening, but we do see like an error statement here, like error processing operation, and we see like retrying in 2 seconds, right? So the Dapr sidecar is like actively retrying something now. So now let's start application B. Happening, and now we see that the request has successfully completed. Right? It took a long time, like 16 seconds. But we also see here that application A logged a recovered processing operation after 6 attempts. Right? So we do get some information back on how many attempts it actually took for it to be like successful. So this is like a good example of how to use like resiliency policies in Dapr. So this is the resiliency policy that is using. Like I mentioned, you don't have to configure this yourself because Dapr already comes with like a decent set of default configurations. But if you want like more control, you can update these yourself. In this case, I am using this policy. It's called my constant policy. You can either have like constant retries or retries with like exponential backoff. So it's really quite nicely configurable. So one part is configuring the retry. You can also configure circuit breakers if you want. But the other part is where to apply this retry. So in this case, my target is application B. So it's an application, and my retry policy is my constant policy. You can also apply retries against components, right? You can have like outbound or inbound retry policies as well. So you can be actually very granular and precise and have different types of retry policies for different types of resources. Okay, so the other example is like an outbound a component resiliency. So in this case, we communicate via the Dapr sidecar to a state store. So let's do that. And in this case, again, Dapr has like built-in defaults for all these things. They have like very long names. So this is the default state store component outbound retry policy, and you can override it if you want, if you use exactly the same name. So I've like created an override for exactly this retry policy, and I made it exactly the same as the HTTP service verification one. So this is a constant policy. It will wait 2 seconds, and then it will like continue indefinitely. Okay, so we can also simulate that. Let me go back here. I'm going to use the Dapr multi-app running game because I'm now running application A and B again. But what I'll do now is I will stop the Redis container. So I'll actually make my state store like unavailable. So I'm stopping the container now. All right, so now it's stopped. And I will copy the command to start it, but not execute it yet. All right, so now I'm going to make the request, then I'll wait a couple of seconds, and then I'll start this Redis container again, and then we'll see that it will complete the call again. So I'm going to send the request, and hey, it's already completed. Oh, I did start. Thank you. Okay, stop it again. There we go. Okay, make the request, and now it's not doing anything indeed. And here we see it again, error processing, retrying in 2 seconds. And indeed, now we can start it again, and then it will actually, indeed, finally, after 4 attempts, it's successful again. Right. So this is another example of how to use different policies. All right. I will not show the final one. What I do want to show you is if you're really serious about production readiness. Well, where is this? Whoop. I can definitely recommend you to take a look at Conductor. That's one of our tools that we built on top of Dapr. So if you're running Dapr on Kubernetes, we have this free tool that you can use to increase your production readiness of Dapr workflows, Dapr workloads. One of the things that we have is there's an advisory, and that's focused on reliability, right? So we have like different types of rule sets. One of these rule sets is reliability, so it will scan all of your component files and configuration files, and then we like give some suggestions what are then best practices to run this in production. All right, so I hope you give you some good overview of what Dapr can mean for you to build like reliable distributed applications. Hopefully you'll try out Dapr Workflow. I've got a couple of QR codes to share with you if you want some more information. So this first one here on the left one is the link to this repo that I'm using, the resiliency and workflow demos. If you want to try out Conductor, it's a free tool. Feel free to scan the other one. If you want, and you've been very patiently listening to me, I've got another QR code. I'll wait until you have taken a picture from this first. All right, so the final QR code, you can claim this Dapr Community Supporter badge. It's a free badge to claim. It's not an NFT, but I've created a lot of digital badges for the Dapr community. There are also badges if you write a Dapr blog post, or if you create a Dapr video, or if you're contributing source code or documentation to Dapr. So there are different ways to claim different of these digital badges for Dapr. And finally, please vote. I will hope to get some green votes. If you have some comment suggestions, please come see me. If you want some more Dapr stickers, I've got a couple of left if you don't have a Dapr sticker yet. So, and thank you very much.